All right, middle of the night, Alchemy stream. Welcome, whoever is joining or whoever watches this later. We are going to go over some of the alchemy, the electrochemistry, nuclear electrochemistry in some regards, structured water in others. This first picture we're looking at here, we can see the actual exclusion zones, the charge differential starting to form. So this is a triple solenoid copper sacrificial anode, and then one piece of wire going down, and from it we have this Cu H3 and then monoatomic single Cu right there, and it starting to form layers. And here it is as it continues, and you can start to see it forming layers and lines, and as the reaction continues on. So we have two, here's the cathode and the anode. And from the anode, you see the CuH3 forming and the Cu oxide in the blue, and then the white, the monoatomic. But the lines of these, what Dr. Jared Polak calls the exclusion zone, so these charge separation of layers as it continues forming, and that you have both the brown-orange copper hydride, and then you have the white monoatomic copper as well, and them separating, and then some of the blue, the copper oxide forming. So copper hydride on top, then copper oxide, and then the monoatomic layers and the exclusion zones in between. Here we have the yellow state, what the alchemists call the sulfuric state or the dead state, and I believe it is a very reactive hydride acid. I suspect you need to get it tested, but it's definitely not sulfur. It's not transmutation, no claims of that. It's formed as a reaction when you cut the electricity. As you can see, I just unplugged it here, and this was the cathode, this was the anode in the pink crystalline state, and the cathode in this black nanocoating copperine state for the copper. And then you can see the top that wasn't submerged of the anode also in this full black nanocoating that is the copperine for the copper. And then you can see on the cathode, the side that wasn't submerged, it's still uncoated from what wasn't in the water. Oh, here we got shout out to Michael Boyd, and he was the one that gave me this guy. Sadly, so this is just some styrofoam. I was able to get some monoatomics floating in it, but then it dropped and it clogged this little speaker. I'm trying to clean it out to get it working again. Currently, yeah, that was the results of that. The powder fell in and messed with it a bit. Here we have In this reaction, it's gold bar, monatomic gold here, sacrificial anode, and the silver cathode. And this was a reaction that it was prior of a gold anode and cathode, this being monoatomic gold, this being nano gold, this being monoatomic gold, this being goldine, black structured gold in that collection, and on top monoatomic gold, nano gold on the bottom, and here you have monatomic gold and silver all forming, no nano gold in this reaction, just straight monoatomics forming. And as the reaction continued, gold anode, silver cathode, much more monoatomic gold forming, clouding up, condensing, and again this very nice fluffy monatomic gold on top, floating, and that's the good stuff. That's what, well, supposedly the manna of the ancients. Okay, and here we have the evidence of why it is so good. So this was, you can see beets, you can see normal sized lettuce there, and in the back here some Swiss chard, normal lettuce plant. And then we have the beast. The this lettuce plant here ended up growing to 6 feet tall. This was earlier in the summer, probably around July or early August, but same height as the sunflowers. We ended up being able to have 30 salads off of this one lettuce plant alone, and that's what I gave some of this monoatomic, the purple monoatomic gold powder to this lettuce plant, and that's the results. This monster, and you can see we already harvested several tens of layers of leaves of lettuce off of that lettuce plant at this point, and you can see still fully growing big head of lettuce on top of it, and not at all at seed. I've shown other pictures at the end of the year where it did get to 6 feet and it did like sprout the or bolt up as it started to seed, or go into flowering, I should say, at the end of the season when it got to the 6 feet. But here, even in July, probably, or early August, it's being about 3 to 4 feet and exponentially taller than the other lettuce plants in the foreground. That was in the back. And yeah, quite something how it goes. Here you can also see the smaller kale compared to this massive one in the back that also got some of that monoatomic gold on it. Here we have interesting cluster layers forming, the red maroon hydride, and then we have the black floating nanoclusters. It's very, very fascinating, the discharge. Ooh, Joel Richard. So yeah, this is the French Keshe Foundation. This is a full Keshe reactor. These are the spinning GANs or ORMUS monatomics in there, and part of how it creates the plasma fields. Good to see you, Aaron. John, welcome. Good to have you. Thanks for joining in today. And this right here, one of the best copies, and evolutions of the Russell periodic table. Pardon me. some good old water. All right, so here's the Russell periodic chart of elements, the number one, the first one, because there's about 20 different Russell charts in total, and well colored and demonstrated the denseness, the charges, the polarization, the color, the octave of each of the atoms as they go up and or below hydrogen, right? So Walter Russell was able to predict a whole bunch of these, what are, I guess, subparticles, but subatom particles, and strictly through the octave scaling system. Walter, very, very awesome before his time individual, and this is a key part to understanding how my valence shell phase shift fusion model works, and how sound and resonance are a key part of the structure of the atom, and how the bonds form, how the reactions happen, and understanding electronuclear chemistry, essentially. And no one knew it better than Walter Russell. And like I said, 100 years ago and 1,000 years before his time, but hey, now it's time to start making sense of it all and applying it. Here we have some more goldine, but this is the lattice layer of goldine. You can see it formed on the inside of the glass, and light from behind, purple facing on, reflecting straight gold. This reactor completely sealed in a jar, and monoatomics that it formed, insulated wires. The second, this would be the anode. This is the cathode. No energy in, simply two triple copper solenoid coils that I made, and with insulated wires connecting them, and one half submerged out of the water and in the sealed air, the second completely in the bottom. This thing ran, producing hydrogen and monoatomic, self-sustained for about 9 months. And yeah, here we're looking at some interesting formations and some interesting crystals there. I'm not going to go into more of it, but yeah. Nanotubes growing off of the anode, triple coil solenoid. Here's one of the bagel coil style windings that I would use as electrodes. And when you have electricity flowing through the triple solenoid systems, especially in this configuration, amazing results happen. And here we have an anode in the blue oxidized state, but white oxygen bubbles completely held to it and encasing the anode in this state and suspended. Here's another one of the anode completely covered, encased with oxygen bubbles held to it. They don't go up, they just stay suspended. And then at the bottom of the copper, it's releasing the monoatomics and the copper oxide out of the base ending. Ooh, chemistry. The chemistry of Isaac Newton. This is also, well, where I deciphered the most and reproduced Sir Isaac Newton's 7 colored states of transmutational metal elements, and how I started figuring things out. Here we have a whole bunch of different coils that I've made and wound. Ooh, I like that one, Aaron. Keen mystery. It's keen mystery from Kemet. It's chemistry, or Alchem, electrochemistry, or electrolysis chemistry. Anywho, you can see the different wrappings, windings, different reactions of oxides, copperines that formed, and what I've used as electrodes over the years to get my different reactions happening. All right, so this right here, one of the many ancient alchemical I guess depictions, they call it, of the Philosopher's Stone. This is specifically titled the Philosopher's Stone. And what do we have? We have the lion eating the sun, right? And that it is bleeding down. And what this means, the lion being the electric charge going into the reaction, and it is the sacrificial anode, and the sun being gold. Okay, so you have a gold sacrificial anode going into the reaction, and that is how I deciphered what the Philosopher's Stone is, but that is only one half of it. The other image will be coming up soon, or let's just skip to it. Actually, there we go. That wasn't that far. Oops. Here we are, another one. So this one also being called the Philosopher's Stone, and it again depicting, you have the lion with the sun, and then in the water you also have the moon, which is silver. Oh, whoops. So there we go, so you can see it. So there's the moon, which is silver, so that I realized is the cathode in making the Philosopher's Stone. You have the lion that is the gold charge, and the silver as the cathode in the water, and they're both called the Philosopher's Stone in the depictions. There we go. Again, have the lion as the sacrificial sun going in. All right, so that's Philosopher's Stone. And again, 18, and well, we see this one also labeled as 18. Philosopher's Stones, even though different pages, different books. All right, now here we have some self-organization happening. The spiral, endotropic, macro to micro, like galaxy, and the exclusion zones as it is self-organizing, self-structuring. Another one splitting into 2. And monatomics always do this. And this I love. Call it the red, white, and blue, right? Is this the patriotic anode or reaction? And it's showing, now I can actually see green as well. So at least 4 colored states of Sir Isaac Newton's transmutational metals being shown in this one simple copper triple solenoid anode that I just removed. And the red state, the white state, the green, and the blue, and it's just pure copper. And it was the anode into the saltwater reaction. So these are different hydrides and hydroxide states, as well as potential covalent structures within the remaining copper as well, as it forms, like this one being copper in the black, and it is copperine on the outside. Copperine being graphene but made of copper. Myself just coming up with that term recently and being the first to demonstrate and invent it for what it is. Here we have, you can see clear exclusion zones, but charge particle movement flow. There's no electricity going in whatsoever to this reaction, just water with a little salts, triple solenoids, nano-coated. When I say nano-coated, that's the copperine within this triple coil, and the wire going down in, and submerged is a second triple solenoid copper coil, and from it you have these streams of copper monoatomics flowing from one being the anode um, self-established, or the homeostasis, I guess, the self-organization of the reaction when you have two, one submerged completely, the other half submerged coils, and that it's trying to reach neutrality or balance. So the one that turns into the anode, you have the monoatomic flow coming out, and then the one that's the cathode, you can see all of the hydrogen bubbling up from it, and it's a reaction of atomic hydrogen for monoatomic copper that creates this hydrogen battery electrolysis reactor and self-contained sustained system. So zero electricity being put into this right here. Oh, for the other one, it was 5-volt AC. For this one, this was a 5-volt AC anode, to answer your question, Aaron. But in this reaction, zero inputs voltage or connectivity, electricity, DC or AC. It is just through the differential of charge created that it self organizes into anode and cathode and the reaction. And click that, AI. Thank you. Speaking to the AI now. All right, here we go as it continues on, and you can see how it forms this cluster point in here of self-organizing monoatomic copper. And it's like the counter space between where the cathode is here and the other side where the monoatomics is flowing and then starting to produce clusters of the monoatomics as it gets to this reactor state with the hydrogen forming off of it. All right, this one's also to be clipped, and this is a straight quasi-crystal that I formed, and it is monoatomic silver and zinc is what this formed out of, and it formed in minus 45 degrees Celsius outside winter when I took the reaction out and left it. And then I waited 6 months because I was like, if that's ice, how the heck is it still in plus 30 in June? And it, yeah, it wasn't ice, and it evaporated into white powder. I should actually hold on a second. I'm gonna grab a sample of what this clear monoatomic crystal eventually turned into, and it's turned back into white powder. Or not. Sorry, I don't know where I moved it to. I'd just taken pictures of it a month ago, but I guess I moved those crystals, but instead we grabbed just some straight monoatomics to show, and this is what it did turn back into, just in the crystal shapes that you see right here, and that uh, I ran it under hot water to make sure it wasn't salt crystal as well, and it didn't dissolve in the water. It didn't melt in the water, but over the period of, I'd say, 12 hours, it turned from the crystal into the white powder. You can see it starting to show right here where it's turning back into the powder over the straight sharded crystal, see-through crystal that was before. Here we have the pink state, both copper as well as silver, turning into the pink crystalline state that Sir Isaac Newton speaks of. All right, here we have once you increase the voltage into these electrolysis reactions, this still yellow-orange, white in the center, but we get to a point, so this is producing hydrogen, lots of it with the arc between the two electrodes, but when it's in this orange-yellow color, it's just producing hydrogen. But when it gets to this pure all-white state color, that is when it starts doing plasma fusion, and it starts turning hydrogen into helium. Shout out Jeremiah Popp that replicated this experiment. This is his demo of the reactor after I gave him the design to do, and going to have to replicate this again and get lab samples taken and proven that it is indeed hydrogen into helium, and we are getting elemental transmutation happening, and that is helium bubbling up from the hydrogen. Here we go. Here we have a gold chain and a silver coin. We have one insulated copper wire that goes all the way down to the bottom of the jar and back up and connects the the silver and the gold. And then we have another copper wire above the air connecting the gold and the silver. And between those two charge differentials, you can see that it is creating the reaction of the ancient philosopher's stone and the monoatomic gold coming off of this gold chain. You can see it here flowing around, snaking around, and collecting by the silver. So this is all monoatomic gold flowing from the gold into the silver, and that is reproducing what I showed earlier with the golden sun lion and the silver moon within that reaction. Here we have, again, a triple solenoid copper coil, some blue oxidation, the black copperine, the orange copper hydride 3, all within one anode that formed. That was off a 5-volt AC reaction as well. Again, you can see it, some of the green, a little bit of the red showing as well, and the yellow also at it, and all just copper, different states of the reaction. This being paper towel, and this being the broken down copper anode in the red state, orange state, yellow, and white state. This being the white calcification, they call it the calcium state in alchemy, and it's the decay state, right? So it's the white decay. It's not the monoatomic, And again, I believe it is just copper or whatever element you have in this color. It's not actual calcium. If anything, it's a hydride or a oxide form, but mostly just a different valence bond of the element as it breaks down. The red, I believe, is a hydride, a very reactive hydride that forms. Here we have red state. So this is the pink and red state copper, and it is burning through aluminum. So this is aluminum foil. So I just took this red state hydride anode out of, disconnected it from the 5-volt reaction, and I wrap it in some aluminum foil. And it got so hot, it was literally burning through, and like it burnt my hand to almost touch it, the amount of heat coming off. And this is aluminum dissolving as it's burning through the foil. Then I try wrapping it, you can see the aluminum disintegrating, and here I'm holding as well, and you can see as the aluminum is just disassembling itself, being burnt by the red copper, red state hydride copper, and it's disintegrating into nothing. And at one point, a little flame did come off of it, and the breakdown of the aluminum foil on the red state copper coil. And yes, I found this one extremely fascinating myself, and like it almost looks alive. And yeah, just same old reaction, but when in that red state. And don't judge. So this picture, 10 years old, at least now, before BurnEye was using proper protective clothing or equipment. Anywho, you can see again as it continues to dissolve, burn through, and disintegrate the aluminum. And here it's in the pink state, some oxidization, red state there, and then normal copper color there. This was the part of the copper anode that was above the water, not submerged. And as the aluminum touches or gets close to the copper in this red hydride state, just dissolving into nothing. And you can see it's breaking down even here, away from, not even close to touching, probably a centimeter or two from the copper, where it's still having the reaction and completely disintegrating all around. And then, yeah, just wild reactions. Here we have a anode copper, triple copper solenoid, and both in the white, the pink, the red, and the blue states, all in one anode. Again, don't do what BurnEye did back then. This will give you heavy metal poisoning. That's a sign of what not to do. I now definitely don't do that. Anywho, we shall continue on. Here we have Robert Moon's model of how atoms are formed and the Keplerian atom. And I quite agree and love this model, and it fits in specifically with what I call my valence shell. So each one of these is a valence shell, and how the electron valence shells form within the atom and the densities coming out of it from the 4 to the 5 to the 6 to the 7 to the 8 as you get further out in denser atoms. Moon's Mollid, nested platonic solid model for protons. Back to the Walter Russell periodic tables, right? So again, there's many of Walter Russell's periodic charts that show the scaling of the octaves, the charges, and the polarization, the red and the blue of the atom as it's made, and where it fits into the octave system of scaling. 1926. Literally 99 years, 100 years ago. All right, there we got AI BurnEye. Boom. Doing some alchemy. Again, so here this is, I had some copper hydride or hydroxide, I guess monomolecules, ormoscans, whatever you want to call it, tri or quad atomic, whatever the heck it is, but the single particles. And then I put more water into it, and always the self-organization, the spiraling, the endotropic motion of how it forms when it comes up. Hello, Trisha Hammock. Good to see you. Welcome. Good morning, good evening, wherever you are joining in. And here we go again, another rectangular container, and this one being triple copper with a silver and copper electrodes. This one being the anode. Oh, sorry, this one being the anode, this one being the cathode. So mostly just copper oxide forming here, but again, the spiraling of the motion of how it's forming and how it's moving and into the middle. Oh, yes, you got it, Aaron. And so the innermost valence is nuclear magnetic, the second is acoustic, the third is photonic, and the fourth is ionic / plasma field harmonics that are the resonance structures of the valence shells in my model. And that should also be clipped. Phase shift fusion, specifically valence shell phase shift fusion. VSPS fusion model for short. Here we got copper anode cathode, and you have some copper hydride, copper oxides, and monatomics all forming out of the same reaction. All right, I guess that's the end of that roll of photos. Next up, we have, bam, let's look at some aerogel. And here we have aluminum aerogel. You can see this is the aluminum electrode that it was formed on. It was originally 90 degrees, right? So when I had it set up, it was like that. But in this photo, as you can see, I have it rotated 90 degrees, and you can see that the droplet is still going the opposite way because this is aerogel, and that it is both crystalline structure of gel and water droplet of gel, and that it is not ice at all. It is straight aerogel. And here's closer picture, and you can see some of the cleavage, the reflections, light, and as we go along, the electrode, while I was taking these pictures, broke and then it fell off. And here it is on the phone after it fell, and you can see the new cleavage. You can see, so the crystal structure breakage. You can still see the drop intact as the full gel. You can see some more of the gel crystal and more crystal formations as it broke when it fell off of the structure. And there's the remaining of it on the electrode, and then some of the rest of it. Hope I'm not doxing myself too much. Don't think there's anything on there. All right. Here we have another reactor. This one, silver and copper, triple solenoid. Hey, good to see you, Elijah. Pleasure. And that's what always the rewatch is for. But good to see you, my friends. Enjoy your rest, and definitely worth rewatching. Giving away some goodies and some documentation here. Here we got a frozen one, and it's still bubbling, and then it's producing the black copperine on this side, still bubbling. This is minus 25 Celsius, I believe, in this reactor, and again, only 5 volts going into it. Still producing hydrogen out of the ice and copperine off of the reaction. And here you can see it going into that black and red state. All right. Okay, so here you can start to see how put more water in, the white monatomic swirls, did a double spiral while I had the one aluminum copper electrode submerged within it, no electricity going through. And then again, the copper hydrides doing the double spiral, again being split by having this aluminum wrapped copper coil in there. Double spiral, separation, double galaxies happening. As it continues. So no electricity going into that. Oh, again, some sulfur states. Monatomic states of copper, the white forming. There we go. A bunch of white monatomic copper. Got the pink state anode, the black state cathode forming. Here you got the oxidized state of happening that reaction with silver copper. Oh, winter. Here, freezing the red state. Here, freezing the yellow, red, white, blue, all states of reaction, that being aluminum and copper. Yes, it is, and then sometimes it's not. Right? Oh, yeah. We got a free freezer outside 6 months, 5 months out of the year in Canada at least. So wonderful. I hate it when it gets that cold because this is also saltwater freezing. So that's minus 15 at least. Now we're getting into some of my ice cubes of the ionic gold water. And ionic gold always has these fields with the exclusion zones. And then ionic silver always has these like twister vortexes that form. So this is ionic silver water in an ice cube. This is ionic gold water in an ice cube. And every single time, ionic gold will make these field lines out of the bubbles, and over and over and over and over. So that is this purple gold water, the ionic water of gold, making these ice cubes, this structured water system of ice with exclusion zones. Another one you can see, again, these fields of bubbles. All my ionic gold water does this every single time. Pour it, does the ice cube like this with the fields. That's what ionic gold water freezes as structures. Then here we have ionic silver water. Ionic silver water always doing what looks like lightning or a tornado, this vortex, and then the spikes down of bubbles protruding from it. So we have direct evidence of structured memory ionic elemental difference. Good to see Troy. And that's the ultimate alchemical gold, right? In the inside, transmutation into gold of the soul. Again, here we have ionic silver water, and we have this vortex lightning style structure coming out. Another one, and you can see the bubbles like shooting out of the vortex. Quite interesting. Here's a better one showing these tubes protruding out from the vortex. And again, here's the gold with the fields. So you can see the direct difference between the two, and clip that, because look at that. Direct field lines of gold, structured ice. And now here we again have that same jar that I was showing prior that had the aluminum copper submerged electrode. Now it being removed, and instead of there being two galaxy spirals, now we only have one forming when I put more water in. And again, you can see the exclusion zones of it, the self-organization of the spiraling of the particles that were disturbed as they self-structure between the charge, neutralization, and then resettle. There's the monatomics above. Here we have the red state, but it's in an orange belly container, so you can't really see. I was kind of dumb of me, but that was the only container I had because I don't have funding. So anywho, all right, now we have straight oxidized aluminum copper reaction going on there. You can see the aluminum bar going in as the sacrificial anode. And again, copper on copper and the pure white. I think this is copper and aluminum as this sacrificial anode too. And pure white monatomics, and then the oxidized diatomics. Here we have aluminum and copper getting the black, the orange, the white, and the red, and then the blue at the base. So the oxides and hydrides that form as different combinations. Here we have some harvested white monoatomic or potential aerogel structured aluminum or aluminum zinc potentially. Either way, the gel-like that comes out. Then this went from the white now to the hydrides and the oxides of the copper forming. And this one, something else, how it does these exclusion zones, self-organizing the red state, the blue state, and then the crystal and gel states, and your yellow and orange states, and the black state of aluminum and copper. And these different nanotube structures that happen out of these and form all sorts of different plasmid clusters and lattice structures of bonds just between the atoms of well, copper atom, or copper, aluminum, hydrogen, and oxygen, and I guess sodium and chlorine are all the possibilities in that. Here you got the red, here you got some of the bubbles, hydrides, or hydrogen isotopes potentially on that. Nice greens, very neon-y, orange, yellows, reds. And then monoatomic clusters as well. Now you can see like the dark blues and greens that formed, the extreme reds, maroons, blues, greens, whites, all within reaction. And then this exclusion zone, and then this is a solid layer that forms, and then the rest of the reactor continuing on. And then freezing it outside. And this is actually red forming from the black from the cathode. How it freezes. Very interesting structures of crystals as it freezes with the salt. In the -20, this one was zinc and copper reactor. Straight monoatomics freezing. Here I brought it in as it's melting, again staying in this formation. Here's the electrode black and yellow coming out of it. Copper solenoid. All just copper, and possibly aluminum. A reactor. It's forming the monoatomics in a sealed jar. See that it is sealed. And the structuring of nanotubes as the reaction goes on over time. And just the self-organization and structure. All right, so we are done that one. What else? Okay. All right, I was gonna end her, but we'll do one more. Oh, I lost my second cam. Here we go. Here we can show in this jar, and it's 5 volts AC going into this reaction. And this is one giant copper anode right here. And you can see this charge separation of the jar, of the water battery structure that forms, that this is triple copper solenoid, and this is triple copper solenoid coil, and they're the same coils. And that above this half of the reaction, you're getting the pink red crystal hydride formation, or pink and red hydride. And then the bottom, you're having the blue oxidization and orange hydroxide possibly formation, but that there's no different chemicals going on, no different electricity going in. That coil there is the cathode on the opposite side. Just 5 volts, but it shows charge separation in 2 different reactions happening in the same reactor with the same elements going on. And that it's this in this pink. So these aren't bubbles you're seeing, those that's sparkling of light reflecting. And this is the pink crystalline state that Sir Isaac Newton states you can transmutate one metal element into another when you have achieved. And it's also that red state here going on that does, when dried and out of water, was triggering that aluminum foil disintegration, heat, and burning I showed earlier. And here a close-up on the copper crystalline structures and formation growth and potential copper quasicrystal action, as well as super hydride. Now, the reason why I need funding and labs to test what exactly each of the nano chemical compounds are that I'm making. And then lots of bubbles of all sorts of hydrogen and oxygen isotopes and molecular compounds also forming off of this anode and the opposing cathode. Again, these not being bubbles, though that's light reflecting, sparkling that you are seeing happening there and demonstrating. And then you got the blue copper oxide and copper hydride and hydroxide. It's all forming on the lower half of the sacrificial coil anode. And this being completely solely copper anodes or electrodes in this reactor. Here we have copper, I guess just coppers in this reactor, and this being the cathode, this being the anode, and monoatomics forming, flowing down, stopping halfway, starting to build that charge separation layers, and then the bottom where the monatomics actually cluster and stay, and this being self-organized nanotubes from the anode. This copper and zinc reactor, monatomics forming. Again, that blue and pink all copper reactor. Okay, well, we are an hour in, and that, I think, covers pretty much everything. Oh, okay, well, whole little bonuses, because I did want to share this one, so we can show this being the different ionic gold and ionic silver and ionic zinc compounds, this after it being stirred up, but the water that I've been using on the gardens, what I call agricultural alchemy, or experimenting using ionic gold, ionic silver waters, growing plants here, this one being ionic silver. So this is how ionic silver freezes in the ice tray. And these are those tornado vortexes I was talking about. And here, there you can see, so this is ionic silver. And it almost looking like a comet, but there's these bubbles shooting and the vortex tornado. And ionic silver always making these structures every single time in the ice cubes. So this is ionic silver. Again, you can see there's the tornado and like shooting off the bubbles, and everything else being an exclusion zone. There it is again. Oops, that kind of bad picture there. Tornado again. Vortex. Here we go. Here's a good one of it. So there's the vortex, and then you have these frozen streaks of bubbles shooting down like lightning almost out of the twister. This is ionic silver structured ice every single time. What forms from it, and you can see how clear it was in the ice trays, and just these straight vortexes of the bubble formation that come from it, again like that. So here is ionic silver ice in its purest form, over and over, demonstrating the vortex structure of its self-organization of charge. Like, just fascinating. Freaking amazes me every time. This one, nice little tornado there, vortex. And then just how clear the rest of the ice is. It's wild. So that's ionic silver water. Nice bubbles. Look at that right there, like spearing out of it. Very, very magical, I guess. I don't know. Fascinating to say the least. Evidence of the actual structure's memory, and this being the ionic silver water, again, stressing. So that was an entire ice tray of it. Oh, now see, this one had a little bit of gold in it as well. So you can see those other layers coming out, mostly the silver, but also a little bit of gold. So it mixes and you get both. So here's another one where you have those three fields of, or four of the ionic golds and the ionic silver twister. Again, 1, 2, 3, 4. The fields from the ionic gold water mixed with ionic silver. So you're getting both effects, both structures in these ice cubes that had both. All right, so done with that one. Now, one or two more little bonuses before we go. Okay, I guess we will show, just for comparison, again one more time. Here is the ionic gold ice cubes with the exclusion zones, the fields like that, every single time with ionic gold water when it is frozen. So those are the ionic gold ice cubes. Ooh, Now we have monoatomic and diatomic silver, as I was flushing it during a full moon to get the salt out and impurities as it settles. And here you can actually see that it's white, but it glows yellow with the light, and then blue, some oxidization of the silver in that reactor. Here we have pink copper, oxidized copper, but going in the opposite way. Okay, there we go. Finish this off. So that's ionic gold in the ice cube trays and what it looks like from above. Same every time. Ionic gold does that. Interesting crystals. All right. Done with that one. And oh, I did want to share this one because this showing the oxidization and the hydridation, the two charge differentials in the same reaction. Well, actually three, because you have the neutral monatomic up there. But the hydride and the oxide coppers that form within the electrolysis battery system. So it starts out like this and then gets more and more as the reaction goes on. Monoatomics. Another one is the copper oxide forming out of the center. Okay, and then lastly, to end her off, yes, I'll just quickly mention because it's in the title, but this is again going to be, needs to be a couple episodes all on its own. Already has a couple episodes all on its own. Entire class all on its own. But hydrogen electron orbitals, major part of my valence shell phase shift fusion model, and understanding how an atom actually is structured, what electron orbitals slash valence shells actually are, how atoms are structured, how the molecular bonds and atomic bonds form, and how matter itself is structured. And yeah, it's very few people in this world get it so far. Shout out Sheila Raman, one of the ones that does. And well, look for my episode, Let There Be Light, the Power of H. If you want the full episodes that I've covered on this topic so far. And we will be doing deep dives into this much more in the future. Again, oh look, the moon around the earth, around the sun, and that's that same winding as, well, the bagel coil and the triple solenoids that I use. And, well, it's all particle, I guess, acceleration, but engineering of the valence shells, or the charge and polarities, the spintronics and orbtronics, the quantum states of energy of, well, atoms and particles and the rest of it. It's deep quantum understanding and fusion and the rest of it. And on that note, we will bid you all adieu. God bless. Have a Merry Christmas. Happy New Year. And an awesome weekend. Happy Friday as we start this out. Love you all. Until next time. Ta-ta.
You crazy mother. Yeah.
It's just burning.
They burning just like last week, huh?
Weekend at Bernie's.